So we have 8 startups here today in the domain of robotics, sensors, and drones. And since we have a number of new people attending this event, I want to just take a minute and clarify what we do here and what these presentations will be about. They're not your traditional startup pitches. These are not meant for fundraising. There's no real focus on business models. Instead, there's a clear focus on furthering partnerships between these startups and corporations, members of the ILP program. And that's where we have a distinct advantage, given we have 230 members, or I think it's almost 240 now, across the globe, across all industries. And so each startup is going to present for 3 minutes. There'll be no Q&A following each presentation. Instead, the intent is that you're going to follow up after they've all spoken outside during the networking time. There are posted signs with their logos, so you can go find them there. With that, we're going to go to our first speaker, David Mindell. He's founder and CEO of Humatics. This is one of our STEX 25 companies from our accelerator program. David is also professor of aeronautics and astronautics at MIT, currently on sabbatical to run the company. And Humatics is developing microlocation and spatial intelligence technology, which enables close interactions between humans and robotics.
It's a pleasure to be here. ILP has been a great part of our company's story from the beginning, and we always find a lot of value in these events. We founded Humatics in 2015 to revolutionize the way that people navigate, locate, and communicate. If you're all familiar with GPS and the way that GPS opened up a whole new world of applications that no one envisioned when those satellites were first lofted in the 1980s, we're building something similar, but at the micro scale. So we have systems that enable us to navigate indoors at the millimeter scale. GPS, of course, is wonderful. It has a 9-meter uncertainty circle in many cases, yet most human and most robotic labor happens within that 9-meter circle. And we expect a similar explosion in many different applications with the hardware and software platform that we're building. We're calling a microlocation spatial intelligence platform. We're about 22 people. We're actually right at the other end of this building on the first floor. Just closed our Series A about a month ago, so we're growing rapidly. I'll tell you a little bit more about the technology. We're focusing on this core problem, a core problem many of you, I'm sure, are familiar with. Right now, there's a great deal of wasted space, wasted capital, wasted equipment, and wasted time due to the lack of close human collaboration with robotics. And based on 25 years of my own work in both navigation and in human-robotic collaboration, we concluded that part of this is because nobody really knows where anything is and knows where it is in a robust way. And the power of millimeter scale, low-cost positioning brought to bear on this problem is just enormous. Our prototype, which is out now and beginning pilots, which will be turned into a product next year, basically something that looks like a router that you mount on the ceiling, maybe a little bit like this projector up here, and then gives you millimeter scale position at very high update rates of these very small transponders, an essentially unlimited number of them, all of them uniquely identified, all of them trackable in a digital way. Actually, the navigation itself is tremendous, but the data that you get out of that navigation is comparably valuable and exciting. Imagine if you had real-time time and motion study every day for workers, robots, other platforms. The world we envision is coming, getting people safely inside the cages, eliminating the cages. Safety is the first level of collaboration, but imagine a world where we know the precise location of parts, people, things, and infrastructure. So we're actively seeking pilot partners right now. Some of you in this room we're already working with, and very happy to talk about further ways to pilot this tremendous technology. Thank you.
Thank you, David. Next speaker is Mike Bayer, hardware engineering director at Vecna Robotics. Vecna Robotics comes out of Vecna Technologies, which was co-founded by a husband and wife team with degrees from MIT. Vecna Robotics makes autonomous robotics for logistics.
Hi, my name is Mike Beyer, and I'm the Director of Hardware Engineering for Vecna Technologies. Vecna is a Cambridge-based robotics company. We're privately funded, and to date we've invested over $60 million into internal R&D. That's resulted in over 125 patents, multiple robotic hardware platforms, and in the words of one of our Fortune 50 customers, the industry-leading robotic navigation stack. We primarily serve the e-commerce and logistics markets, so you can think the Walmarts and the UPSs of the world. And all of our customers have three main needs. One is they need to lower their delivery times. Two is they need to lower their costs. And three is whatever solution they use to fulfill the first two, they want it to be one comprehensive solution that's able to automate all of their diverse logistic needs under one solution, rather than having to piecemeal together a overall solution from multiple vendors. So to that end, we developed this concept called full spectrum automation, which is exactly that. And we divided that problem into three separate categories. One is you need the right vehicle for the task. So whether that's a pallet mover, a tugger, or a lifter. The other is you need some piece of software which is able to orchestrate those vehicles, take orders from our customers' warehouse management systems, break those orders into tasks for each robot, and then monitor the execution of those tasks. And the third component is supporting tools. So all of our customers are able to monitor their entire fleet remotely, and also able to change the workflows after we leave. All of our robots use Vecna's proprietary smart navigation stack. And that stack enables our robots to get a destination and dynamically plan paths to that destination. None of our robots follow pre-programmed routes. It also enables our robots to operate without any changes to existing infrastructure. So we can take our robots into a brand new facility and get them up and running in the same day. It's also hardware agnostic, meaning that we can automate, any existing third-party platform as long as it's drive-by-wire. So our robots have traveled thousands of miles, and since we officially launched our products earlier this year, we have hundreds of inbound leads and active deployments with Tier 1 automotive suppliers, Fortune 50 retailers, and top global logistics companies. The feedback from the market has been that this is the exact product that is needed to stay competitive in today's economy. And we're looking to exponentially grow our operation over the next few years. And to that end, we're looking for $20 to $50 million for a minority stake in the business. And if you're interested in learning more, I'd be happy to speak with you after. Thank you.
Yeah, and just to clarify, that's not the focus of the events to fundraise here. Next speaker is Feng Tan, CEO and co-founder of Wubu. He holds a PhD from MIT, and they're making an educational robot.
Thank you. So hello, everyone. So what we provide here is a cutting-edge speech interaction solution that can be easily customizable for any vertical integration. So in the past few years, everything starts talking, right? So it's from your smart speaker to your fridge to the car to even toys. And on the other side, there is a lack of conversational UI. It's not just asking what's the weather today. You want something to be conversational, to be interactive. But like Siri is closed ecosystem, like Alexa is too broad, too general, and also like there is no personality and emotion in the interactive systems. So for us, we have the cutting edge technology in speech interaction. We have the state-of-art question answering algorithm, which is based on natural language processing. We were the first place in the Track Live QA contest organized by Yahoo Answers in both 2015 and 2016. So our performance was 50% better than all other participants from the other top research institutes of universities. So we can answer questions like, how can I convince my mom to pay for my gym subscription instead of just what's the weather today? And we can put personality into conversation. So it's not just a theory like how can I serve you, but it's something with character, with personality. Right now, we can already imitate any character or celebrity. We have had successful use cases imitating Master Yoda and Donald Trump. So our system is 3 parts. We have an interactive front interface, and we have flexible configuration on the mobile side. And the core part is the AI in the cloud that contains both the algorithm and also the media that you actually want to deliver to your customer. So we already have successful use cases. We developed this educational robot by ourselves. It's right now on Kickstarter crowdfunding, and we have already sold 1.5K units of this robot. All the technology is mature here. We build skills surrounding the vertical use cases about children education and entertainment. And right now, this technology is migratable so that we can be combined with more industries like VR, AR, e-commerce, elderly care, gaming, and everything that is imaginable. So right now, we have already formed strategic partnership with Beijing Lanxem Technology in K-12 education. And also, we are preparing pilot programs with home appliance partners and also toy manufacturers. Thank you.
Our next speaker is Sampriti Bhattacharya, founder and CEO of Hydroswarm. She holds a PhD in mechanical engineering from MIT, and Hydroswarm is making AI-enabled underwater drones.
Okay. Hi, everyone. I'm Sampriti, and I'm very glad to be here. And I'm the founder of Hydroswarm, a startup that focuses on maritime security and data. So I used to be an aerospace engineer before getting into the ocean, only when I realized that 70% of the world is ocean, and we know so little of it, which is our future of food and energy resources. And that's pretty obvious from the fact that it's 2015. And we did not even know how to find a massive 737 airplane. And also, the BP Deepwater Horizon oil spill. Yet, if you break down the physics of the problem, it's fairly simple. I mean, in both cases, what you're looking is to find a particular signal or to search for particular chemicals, how is to track it over a large marine area. And the 21st century solution should have been like low-cost distributed sensor network. Yet, what we really had was like expensive, unscalable, and super complex industrial solutions, multi-million-dollar platform, which you just cannot deploy in plenty. And that's where, we saw an opportunity and where Hydroswarm comes in. The Hydrone, which was developed during my doctoral thesis at MIT, tested, is essentially a plug-and-play sensor system for a wide variety of sensors. And what we do is we provide highly secure marine data and autonomous solution and enable mapping of large-scale marine areas. And all of this is integrated by a single software platform. So the technology has been patented both by patents at MIT and what we have developed outside of MIT from very unique propulsion system. It's a stealth device. It has no propeller, as you can see. It can be made undetectable by sonar, essentially. And it's entirely autonomous, and it's swarm capable. And that allows us applications in different kinds of areas, which we will get into in a second. So these were some of the early prototypes. Our new prototypes are not public, but you can see there's like different sizes, and it's very scalable from like 8 inches to a little bigger than American football. And so where do we work? Our application areas ranges from offshore infrastructure inspection, like oil spill, for example, or like offshore wind, to defense and security, port security, reconnaissance, stealth, even underwater cables. And then, of course, seismic survey. The market opportunities is huge, and we are currently conducting pilots with selected customers. We are very excited about the market opportunities, and if you find any overlap of interest, do reach me out. I look forward to talking to any interested people. So the email is there, or you can find me after my talk. Thank you very much.
Next up is Rory McKean, CEO and co-founder of Franklin Robotics. He holds a bachelor's in mechanical engineering from MIT. And Franklin Robotics is making a robot to weed your garden.
Good morning. My name is Rory McKean. I'm CEO of Franklin Robotics. We're a startup outside Boston. We're focused on outdoor robots with a particular affinity for agriculture. I met my co-founder, Joe Jones, at a company called Harvest Automation, which makes plant-moving robots for commercial nurseries and greenhouses. Prior to being a co-founder at Harvest, Joe was at iRobot for a long, long time and is one of the inventors of the Roomba, the little vacuum cleaner we know and love. Joe and I have this affection for simple, practical robots that can actually get real work done. And we got really interested in agriculture over at Harvest. And so there's a bunch of challenges and opportunities for rethinking the way that we grow our food. And that's what we were really interested in looking at. So first spot we looked at was home gardening. So about a third of US households have a garden or grow food of some sort. It's about a $6 billion market. And when you talk to gardeners, weeding is necessary if you want to have a healthy, productive garden, but it's really painful as we get older. It's harder to bend over, harder to pick the weeds out. Even if you're young and healthy, though, it's really time-consuming and frustrating, and really nobody likes it. But if you want to have a garden that has vegetables and flowers that are really healthy, you need to do it. And so we've developed Turtle. So Turtle is a solar-powered weeding robot that lives in a vegetable garden or flower garden. And every day it'll charge itself up in the sunlight. And when the battery gets full, it'll drive around. It avoids any plants or obstacles or anything that's taller than an inch. And then as it's doing this, it's looking for any weeds. And if it finds them, it cuts them with a little weed whacker that's on the bottom of the robot. So we have a sort of unique sensing approach, which is non-optical. So we use this sensing to this capacitive-based approach because it's really robust and cost-effective, which is pretty important for a consumer product. We made it as simple as possible to use. It's something for your parents or grandparents that would be totally comfortable using. But it is Bluetooth connected if you want to kind of dig in and get access to the data and connect it to your sprinkler system or something like that. So that's Turtle. So we did a crowdfunding campaign earlier this summer on Kickstarter and then on Indiegogo. It's actually still available on Indiegogo if you want to get one. But so we pre-sold about 1,500 of these robots. We're building them now, and we have shipments planned for next spring. And so as we're doing that, we're also we're developing technologies for future products that come down the road. And that's where we're interested in looking for partners that have interesting technology they'd like to work with us on, or other applications that they think might be an interesting fit for us. And that's us. Thanks.
Thank you, Rory. Our next speaker is Lyle Odner, co-founder of Right Hand Robotics. He holds 3 degrees from MIT, a bachelor's, a master's, and Doctor of Science in mechanical engineering. And Right Hand Robotics is making a piece-picking robot.
Thank you. Thank you all for coming, too. My name is Lyle Odner, and I have been working on this problem for a number of years, and I'd actually like to focus on the problem rather than the technology. I have the words intelligent robot order picking systems up there. What we make is a piece-picking robot, and what I mean by that is a robot that can pick up and handle individual consumer products. And just to give you a brief sense of the seriousness of this problem, the changes in consumer demand for retail have transformed the logistics of it. So previously, if you wanted to ship things out of a warehouse, you're typically shipping them to a storefront in case-level quantities. As people want orders shipped to individual addresses, and as storefronts want to streamline their logistics and start doing piece-level restocking in the stores, you have to hire an army of people, and it looks about like that up on the slide, to break up each case of goods and actually pack them in individual boxes for downstream delivery. So what we are doing to solve this problem, we are making a model-free piece-picking robot, and I want to explain why that's important. A typical grocery store has roughly 45,000 distinct products in it, and the packaging on these products changes regularly, sometimes 3 times a year. So if you were going to try a traditional robotic piece-picking system where you were scanning in models or where you were using CAD models of objects in order to plan picking and placing, you would have a truly horrendous data entry problem. So what we are doing instead, we are developing a system. We develop a custom end effectors and a custom vision system, and we'll integrate with the robot of your choice. And we can pick and place objects based purely on what we see of them. And we also have a data harvesting and machine learning component that essentially ensures long-term performance improvement of these systems as they go. Now, where we are today, we are actually out and piloting already with a number of very large companies. We are actively fulfilling orders today. We have picked millions of objects. We are still seeking strategic partnerships, specifically with large retailers, both online and storefront, with shipping companies, and with large warehouse automation providers. Thank you very much.
Thank you, Lyle. Next speaker is Douglas Rowino, CEO of GeoScout. He holds a bachelor's from MIT in electrical engineering and computer science. They're making a drone platform for remote monitoring.
Good morning, and I want to thank MIT for having GeoScout here. GeoScout's a manufacturer of heavy lift drones. We have a number of people who have graduated from MIT who are involved with the organization, and the question I have today is, what 50-pound payload would you fly if you could fly it for an hour? And let me throw in 500 watts of electricity generated on board for you, too. This capability opens up a new market. If you look kind of where battery-based drones are, the majority of what drones are out in the market, you'll see that at the maximum, they can typically fly for maybe 30 minutes, and they may have a minimal payload of 1 pound at that point. And for their maximum payload, they may have about 7 pounds, and they can fly for maybe about 10 or 12 minutes. With GeoScout, with a minimal payload, we can fly for over 120 minutes. And we can fly with 70 pounds for maybe 12 to 25 minutes. And so that's why we say, what do you have that's 50 pounds that you want to fly for an hour? This opens up a number of use cases. For instance, in agriculture, we have the ability to have mounted on board with our craft a sensor, like a multispectral sensor, and also a delivery system, so we can do precision delivery of pesticides or herbicides. In infrastructure, we have the ability, for instance, we've been talking to power companies that have a need for inspecting their power lines and their pylons, and also to detect gas leaks. So in one vehicle, we can mount both these sensors, and in addition, they can fly for quite a distance. Right now, with the battery-based systems that they've been testing, they may be lucky to inspect one pylon, and then they'll have to drive to the next pylon. They basically don't have enough power to fly from pylon to pylon. And in addition, we also have people we've been talking to in security. This is a pretty critical area right now. And in fact, we'll talk about a little partnership we're working with now. But again, it would be nice to be able to mount on a single craft the ability to detect explosive devices, hazardous chemicals, and also to incorporate that with different types of imaging technology. How do we achieve all this? Well, it's not a simple problem, but what we use is conventional fuel as our energy source. We use a 6-kilowatt turbine as our power source. And in fact, that little kind of blurry picture in the background is they use this for electricity, for generating electricity in search and rescue, and that's them testing it up on the top of the Alps. And fuel is just currently 30 times more energy dense than battery technology. In addition, we can generate onboard power. Because we have a turbine spinning there, we can hook up a generator and generate electricity as we need for your payload. And that's a big benefit because now you don't have to carry the heavy batteries around. And it also facilitates quick turnaround. We control the vehicle by using variable pitch, which allows us to operate the turbine at a constant RPM for peak efficiency. And because it's a mechanical system, we can have our rotors share airspace, so we can make a very small footprint. So we're currently, our new partnership that we're working with is with Laser Detect Systems, and they have an aerial spectrographic system that utilizes a UV laser to illuminate a target and detect chemicals and then get a signature back that they compare to an existing database. Our vehicle has a capability of carrying many other sensors, and we look forward to talking to you today. You can look at the vehicle outside.
Great. Oh, the clicker. Thank you. Great. So our final speaker is Maha Haji, co-founder and designer at Flight Infinity. She holds a master's and PhD from MIT, and they're making a high-speed, long-range ocean monitoring drone.
So thank you, Marcus, and thank you to the Startup Exchange for having us here. So I'm here with Flight Infinity, where we're bringing the high seas to the data age with a wind-powered drone. So this is technology that was developed at MIT with my co-founder, Gabriel, as part of his PhD in mechanical engineering. And so looking at drones today, they are segmented into consumer, commercial, and military markets. And they can range in cost from $1,000 to millions of dollars. However, all of them are limited by endurance. So, and that really limits their use cases. So in the case of consumer-based drones that can fly up to 45 minutes currently, they really are limited to doing work within city limits, perhaps monitoring agriculture a little bit farther out. And military drones can fly up to a day, and this enables them to go slightly farther away, but they're still limited to near-shore endeavors. And at Flight Infinity, what we've done is we've developed a drone that has much longer endurance and is provided at a price point of consumer drones. We can fly for days on end, which opens a whole new market for us. And specifically, we believe we are best suited for ocean monitoring and applications in that space. So how is ocean monitoring currently done? We use very large assets such as ships, survey, aircraft, and satellites to monitor the oceans. These assets have to be very large to carry all their fuel with them to take it so far offshore, and then they have to take all crew necessary to operate the vessel. At the same time, sensor technology is getting extremely small. So this is a methane sensor that actually fits in the palm of your hand. So there's a huge mismatch between the assets and the payload that they carry. And at Flight Infinity, we believe we have the solution. So how do we do it? Well, we have taken inspiration from Mother Nature and the albatross. This is a bird that does not flap its wings to fly for very long distances. It actually extracts energy from the wind as it moves itself, and it can fly for 1,000 kilometers a day at very, very high speeds. So we've developed a drone here at MIT that can do the same thing. This is work, as I mentioned, out of Gabriel's PhD, and so far we've tested a prototype that has proven our theory, proven that the prototype works, and we're able to maintain extremely low height control above the ocean, which enables us to look at very interesting spaces. And all of this is patent-pending, proprietary sensing and control technology. So let's take a look how it might work in the ocean. So currently, if you want to survey some area in the ocean, you'll send usually a large research vessel. And it will monitor the ocean along one transect or one line. And since it's so expensive to do that, it can only do it once a year, twice a year. With our drone, we can take a much more interesting path, covering much more of the ocean. And because we're so low cost, we could do this multiple times a week, if not, instead of just a few times a year. So we can either complement current ocean monitoring technologies or perhaps replace them in certain cases. So we're looking for strategic partnerships for companies that are interested in helping us work with a pilot study in early 2018 to test our technology out. Thank you.
Thank you, Maha. So that concludes the presentation part of the morning, the startup presentation part. The Q&A segment will take place now out there. And we'll reconvene in here for the first keynote at 10 a.m. Thank you.